This is Algebra 2, Unit 6, Lesson 6 on the zero product law. The zero product law is something we've actually used since Algebra 1 to solve quadratic equations. Basically what the zero product law says, if the product of multiple factors is equal to 0, then at least one of the factors must be equal to 0. Now that makes sense when you think about it. We have, for example, this two factors, x plus 7 times x minus 3 is equal to 0. That tells us that something times something has to equal 0, one of them has to be 0. So what we're going to do is we're going to find the values that make each one of these equal to 0. We set each bubble equal to 0. X plus 7 equals 0, and then solve it for x, we get x is equal to negative 7. So if we plug in negative 7, this bubble is going to be 0. 0 times this bubble gives me 0. The other value it could be is x minus 3 is equal to 0. So x is going to equal 3. If we plug in 3 into this bubble, it'll make this bubble 0. 0 times this makes this equal to 0. So the two values of x that make this product true, that make it equal to 0, would be negative 7 and positive 3. Now, 2x minus 5 times x minus 4 equals 0. Set each one equal to 0. And solve. Now this one's easy. Just move the 4 over. It's x equals 4. This one, don't worry about the 2x. It's still the same thing. Move the 5. And divide by 2, x is equal to 5 over 2. Remember, if you have a higher leading coefficient, a lot of times your answer is going to be a fraction. That's perfectly okay. All right, now what if this is factored? 4 times 3x plus 2 times 4x minus 3 equals 0. If we set each of the factors equal to 0, we have 4 equals 0, 3x plus 2 equals 0, 4x minus 3 equals 0. All right, now these two look like what we've just been doing. We get 3x equals negative 2. So x is equal to negative 2/3. This one is 4x is equal to 3, and then x is going to equal to 3/4. But what happens right here? This says 4 is equal to 0. Well, when your greatest common factor out here is a constant value, it actually will divide right out. So this is 4 equals 0. This would be no solution for this particular one. So 4 doesn't affect the problem. When we usually have a problem like this, we can completely divide out the greatest common factor here and here, because 0 divided by 4 is going to equal 0. So we really don't have to worry about the constant value. And so in exercise 1C, why does the factor 4 have no effect on the solution set of equations? Because 4 does not equal 0. So we don't have to worry about the constant value. We can divide it out. Now the zero product law can be used to solve any quadratic equation that is factorable as long as it's not prime. So basically what you have to do is get the equation equal to 0, factor, 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 set the factors equal to 0, and solve. So when you have a quadratic equation, your first instinct should be to get the equation equal to 0. Now to do that, we have to move these two values. So I'm going to add the 2x, and I'm going to subtract the 10. Now make sure you line them up under each one. Watch your signs. This is x squared plus 5x minus 24 is equal to 0. Factor, factor, factor. And that gives me x and x. Negative 24 means it's going to be plus and minus. The factors of 24 that give me 5 would be positive 8 and minus 3. There is completely factored. Now this looks like what we did in the first exercise. Set each factor equal to 0. X plus 8 equals 0. X minus 3 equals 0. Solve for x. X is equal to negative 8. And x is equal to 3. All right. So there's my two values of x that would solve this equation. Let's try another one. 3x squared plus 12x minus 7 equals x squared plus 3x minus 2. Okay, this one has x squareds on both sides, so we want to get it equal to 0. Now, a good rule of thumb when you're doing these is to keep your x squareds positive if at all possible. It's a lot easier to factor that way. So since I want this equal to 0 and I want x squared to be positive, 3x squared is bigger over here. So I want to move this side of the equation over here. So I'm going to minus the x squared, minus the 3x, and add the 2. So minus x squared, minus 3x, add the 2. All right, so that gives me 2x squared plus 9x minus 5 is equal to 0. Okay, now this is factorable. We want a double bubble, but instead of having x and x, what are we going to have for the first term? Well, it's going to be 2x and x. All right, and then the other end is got a 5, so 5 and 1 was what we have to use. But remember, whatever one goes here is multiplied by 2. So do I want to multiply the 5 by 2 or the 1 by 2 to get 9? Probably the 5. So that'll give me 10, and 1 will give me 9 if I get the signs right. So if I want it to be positive 9, it would have to be plus 10 minus 1. 10x minus 1x is 9x. All right, so there's my factors. Set my factors equal to 0. And solve for x. 2x is equal to 1. X is a half. Yes, you can have a fraction. And this one's going to be x equals negative 5. So there we go. Zero product property. All right, now let's look at the system of equations shown below consisting of a parabola and a line. Y equals 3x squared minus 8x plus 5 is a parabola because it has the x squared in it. This is y equals mx plus b, so this is the line. Now, find the intersection of points of these curves algebraically. Algebraically means use algebra. Don't try to put on your calculator and solve it, which we are going to do anyway. But to find it algebraically, what we have to do, well, this says y equals and this y equals. So we want to take 4x plus 5, and we're going to plug it in right there. So it's going to be 4x plus 5 is equal to 3x squared minus 8x plus 5. All right, now get this equal to 0. I want a positive x squared, so I'm going to move 4x plus 5 over to this side, so it's minus 4x minus 5. Minus 4x minus 5, and that gives you 3x squared minus 12x is equal to 0. Okay, so I want to factor this completely. Now before I start, do you notice anything about these numbers? Yeah, everything divides by 3, so why don't we divide by 3? Because if we factor out the 3, it's not going to affect the problem anyway. Like, remember the problem we did with the 4? So I'm going to do that. So x squared minus 4x is equal to 0. Okay, now, when I factor this, x squared minus 4x, is this double bubbles? No, it's not. It looks kind of like difference of squares, but with the x here, that doesn't work. So it is GCF, however. So if we factor out the x, we're left with x times x minus 4 is equal to 0. Set each factor equal to 0. X equals 0 is going to be one of your answers, and then x minus 4, x is equal to 4 is going to be your answer. All right, now remember, we are looking for an intersection point. So we actually have to find a y value that goes with each of these x values. All right, so if x equals 0, we have to find the y. Well, let's use this one because y works out pretty easily that way. 4 times 0 plus 5. And this will be 0 plus 5, which is equal to 5. So your first point of intersection will be at 0, 5. All right, so there's my first solution. My second solution is x equals 4. All right, y is equal to 4 times 4 plus 5, which is 16 plus 5 is 21. So my second point is going to be at the point 4, 21. So that is my solutions to this equation. We found the intersection points of the curves algebraically. The two graphs should intersect at 0, 5 and 4, 21. Okay. So, let's see if we're right. We're going to use the calculator to graph the system on the axes and label the curves, the intersection points, and the window. All right, now we know they're going to intersect at 421, so my y value is going to have to be at least 21 or more. Okay, so why don't we go, just so we can see everything, for the y values, I'm going to go from negative 5 and say 25. And for my x values, I'll go from negative 5 to positive 5. And that way I can get it to fit. All right, so the first thing I'm going to do is adjust my calculator so I can fix the window. All right, so my x's I decided were going to be from negative 5 to positive 5. Scale of 1 is fine. The y minimum is going to be negative 5, but I'm going to go up to 25 so that my whole parabola will fit on the graph. All right, let's go to y equals. All right, let's put in our values. 3x squared minus 8x plus 5, and then the other equation is y equals 4x plus 5. All right, and I want to hit graph so I can see what it looks like. That looks like what's on your paper. There's the graph, and that's what your parabola looks like. Okay, now the next thing I want to do is to verify where these 2 points are. Now I can probably count right on here and see that it's 1, 2, 3, 4, 5, but I want to verify that. All right, now there's two ways that you can verify. You can go to your table, and you want to see where the two y values are the same. So if I go to my table, all right, 0 if 5, that's where it matches. And then down here I can see it 421. So I know those are the 2 points. Now I can also do this algebraically, or excuse me, graphically using the calculator, using the intersect command. All right, so what I have to do is press second and the trace key to get the calculate screen, and we want intersect. Now we did this with linear equations a long time ago, where you just go enter, enter, enter for the intersect. But since we have 2 points of intersection, we have to tell the calculator where to look. All right, now for this first one, notice this popped up when it says first curve. Do I want to use this graph? Yes, I do. Enter. And then the red one, yep, I want to use that one. And this is right about where it is going, so I'm just going to hit enter again. And the intersection is at 0, 5. I can see that. Now, how do I get this point up here? Well, I do the same thing. Second, calculate, intersect, number 5. All right, yes, I want to use the blue one. Yes, I want to use the red one. When I get to the guess one, I want to use my left and right arrow keys. So I'm just going to use my right arrow key to get it somewhere near to where those actually intersect. So when you get to the guess screen, that's where you rearrange so that you know where it is. Okay, so about there, that looks pretty close. Press enter again, and there's my other intersection of 421. So using my calculator to sketch what's on my paper to sketch what's on my calculator, it looks something like this. All right, this went down like this, and then came back up like this. And this was y equals 3x squared minus 8x plus 5. And then the other one was the line, and it went like this, something like this. Oops. There's my line. And my intersection points were at 0, 5, which is this point right here. And my other point was at 421. And there are my 2 points of intersection. Remember, this was the line y equals 4x plus 5. So I can see I did it algebraically, verified it on my calculator using either the table or the intersect command. Now, what do we usually use the zero product law when we're doing parabolas? Is we use it to find the zeros or the x-intercepts of the parabolas. Now, why is it the zeros? Because remember, at the x-intercept, y is equal to 0. So when we have y equals x squared minus 2x minus 3, and I want to find the zeros, all I have to do is plug in 0 for y. Now, let's verify that this actually works. So if I look at the two x-intercepts on the graph, here's my x-intercept. It would be right here and right here. Now, those coordinates are actually at x equals -1 and x is equal to 3. All right, now technically, those are the 2 points, -1, 0, and 3, 0. So because y is equal to 0 on the x-intercept, at the x-intercept, I should say. Now, algebraically, let's make sure that this works. Find the x-intercepts of this parabola algebraically. Since y is equal to 0, we take the original equation, x squared minus 2x minus 3, and set it equal to 0. Factor, factor, factor. X and x. -3 means plus and minus 3 and 1. To get it to be -2, it would have to be -3 and plus 1. Set each factor equal to 0, and we get x equals -1, x minus 3 is equal to 0, and we get x is equal to 3. And you can see -1, -1, 3, 3. We did it algebraically, and we did it graphically. All right, so why don't you try exercise 6, and we'll go over these in class before after the next thing.